This is my presentation titled Excel Histogram Unveiled. I made this presentation as part of the activities of the Centers for Excellence for Agriculture and Water. The contents include a definition of the histogram and the difference between column and a histogram, and then I explain distributional features in terms of different and unequal bin sizes, and how to use the spreadsheet to produce histograms using charts, frequency function, or data analysis. And then I will give some concluding remarks with a special attention to use of histograms in education. A histogram is defined as a graphical representation of data points organized into user-specified ranges. And it's a type of chart that shows the frequency distribution of data points across a continuous range of numerical values. The values are grouped into bin or bucket that are arranged in consecutive order along the horizontal x-axis at the bottom of the chart, as you can see here. It shows you this is different bin ranges, but they are equal, and the color gradation shows the intensity or the numbers of the bins. The difference between column and histogram: column graphs have separated, related or unrelated categories along the x-axis. Each bar will consist of a value that is separate from another and will typically have space in between each bar. However, histograms will group the x-axis values into ranges, and thus the bars will be touching. This is different types of distributional features: symmetric, unimodal, skew left, skew right, uniform, bimodal, and multimodal. If we change the bin size, the distribution of the histogram will differ. The left panels are too small, implying a lot of spurious peaks and troughs. The right panels bins are too large, hiding any indication of the second peak. The bin size in the middle is proper to show the bimodal distribution. For unequal bin sizes, the technical point about the histogram is that the total area of the bars represents the whole, and the area occupied by each bar represents the proportion of the whole contained in each bin. When bin sizes are consistent, this makes measuring bar area and height equivalent. In the case of a histogram with variable bin sizes, the height can no longer correspond with the total frequency of occurrences. Doing so will distort the perception of how many points are in each bin, since increasing a bin size will only make it look bigger, as you can see. Here, the left histogram with equal sized bins. The center histogram is unequal bins but improper vertical axis units. The right histogram is a histogram with unequal bins but with density heights. The y-axis changes from frequency to density. Using Excel, we can use a histogram chart. We can highlight the data and then we click insert, and then we use the histogram chart type, and we get this. The histogram bin width is calculated using a formula that's 3.5 multiplied by sigma divided by the cubic root of n, where sigma is the standard deviation and number is the values in the data source. Here, using the numbers to the left hand side in column A, sigma is 21.784 and n is 27, and this will make h 26. We can change h to a better number from 26 to 20, and we can get the chart you see here. We can use a frequency array function. It's a typical function in Excel that produces more than one answer. Where the answers appear in the rectangular green highlighted area here, and you have to specify the data array and the bins array, and then you can say Control Shift Enter to produce the output in an array, as you can see. Here, this is what we get, and then we can change the x-axis from numbers to classes of grading: fail, pass, good, very good, and excellent. And then we can make the gap size equal to 0 to produce to convert the column graph into a histogram. The bar chart with 0 gap width looks like the one you see here. This shows that the different grading system or the grading system ranges are different. Therefore, the histogram produced in the previous slides are not correct if you go to the definition produced before. Therefore, here I made 3 examples. The one to the left is a histogram with grades. In the center we have a histogram with grades unequal bins but improper vertical axis units. And the histogram to the right is a histogram with unequal bins with density heights, which is correct. Here we can use the data analysis histogram by going to the data analysis add-in, open it and choose histogram, and then we specify the input range, the bin range, and the output range, and we get the same numbers we got before, and then we can make the gap width 0 to get the columns touching. A more intricate grading system used at the Faculty of Engineering where I work is a bit intricate, as you can see, and this is how the ranges of grades are specified. The faculty histogram produced by the quality unit produces 2 graphs, and both of them are correct. The one to the left is grades distribution of final exam, and it is in percentage with equal bins. The one to the right is unequal bins using the grading system, and the y-axis is percentage instead of frequency to make a correct histogram. My concluding remark is that in this presentation I revisited the histogram to explain some intricate issues related to features and how it is produced using Excel, and I gave some stress using an example for educators to discuss bell-shaped histogram for student marks.